So, welcome to the kickoff of our today's sessions on the annual working group update from the ELISA project. I'll start with an introduction about the project overview. So it's mostly for new people joining to get an first idea, and more details on the separate working group will follow after this intro. To get people on board, we're talking about Linux and safety critical systems, so not about security, which sometimes get mixed up. So it's about the risk of causing harm to humans, human life. And in order to assessing whether a system is really safe, it requires understanding the system sufficiently. I guess that's one of my favorite sentences, which I have in almost every slide set. What it means for us is that you need to get an understanding how Linux is used in this system context. This means what's left and right, how is the areas, what are processes, tools used in it, and what is the real usage of Linux. And if you look into Linux, you need to strip it down to certain components and figure out, okay, this is a feature I use, this is something which I don't need. Uh, how can I evaluate it? And if you start digging into it, we can address it. Of course, you will identify gaps because Linux was not made as a safe OS originally. So for this, yeah, also the evaluation needs to take place. And as said, Linux differs from a traditional safety OS. If you think about commercial options, often they get certified maybe some time ago, so it's a longer time since they got in certification mode, then they haven't been updated, but complexity grows, systems grow, and then you may say, okay, how do I handle my whole work? How do I get forward? And I look into this rich ecosystem of Linux, and but then you see, okay, I have still a long way to go for safety. So if you compare both sides, you may end up in saying, either I have to see an argumentation for safety, but I get a rich ecosystem, or I have a safety certification, but I need to spend a lot of efforts to get it handling these complex use cases and getting really like killer application like autonomous driving getting forward. So this is something to be taken from both sides. And in ELISA, we have a forum where we would like to collaborate, but there are some limitations. It's like the disclaimer which I would like to give, even if you do work on ELISA, you uh, will face limitations. We cannot engineer your system to be safe, which basically means that there's a lot of responsibility still to the person who prepares such a system. And we describe processes, tools, elements which can support an argumentation safety. But of course, it's also your responsibility to read it, to understand it, and make a proper use of it. A question which pops up quite often is like, will we have one kernel version which we make safe? And the answer is no, we cannot create an out-of-tree Linux kernel for safety critical applications. So you need to have an update path. There will be features coming in. You may have security issues or new functionality, something you want to make use of. So there's nothing like an safe Linux directly provided by ELISA. It's more on providing you a path toward this. And yeah, last part also important, you still have the legal obligations. So you, even if you do the things, it's not like you buy a product from us which comes with certain liability. It's still important that everybody knows about the legal obligation and do the best to get the system safe. But we still have a bunch of people who collaborate in this environment. So we have premium members like Boeing and Red Hat, a bunch of general members, quite automotive driven, I have to say. And then there is a bunch of associate members. These are not paying members like the other ones mentioned here, but we get a good support for them, or we share a problem space, or their things get together. What the members all overall align on is the ELISA mission. And this is really to define a common set of elements, processes, tools, and that can be all incorporated into Linux-based systems. And the overall idea is that this is amenable to safety certification later on. We do this whole work in working groups, and this is what you have in this annual update. So you'll get an overview on the different working groups in scope. We have horizontals and verticals. Let's start with the horizontal part. We have a safety architecture which looks into the kernel, understands how processes are done there or how the kernel operates. So how the architecture of the Linux kernel looks like. And this goes over partially to Linux features, which is not only looking into the kernel, but also into the kernel. And here it's more to identify what are parts, what are components, mechanisms which can you support your safety argumentation. In security, that's well known. It could be C groups, namespaces, MAC tags. So you have all these kind of little tools which are used to secure your system. And the idea of the Linux features is to provide certain guidance also on this. It could also be like, here is a real-time Linux configuration. And what are the methods to get this forward and to document it properly. Everything is also about tools. So you need to look into tools, how to create your Linux system, which are elements for testing, identify which bugs could be there, build tooling CIs. There's a lot of things around this. You will hear about it later. And then if you leave the pure software world, there's also an engineering process. So you need to follow certain things, how you do requirements, how you write a design. Our open source engineering process work group did also a lot of work on SDPA and other things. I'm pretty sure we'll hear something about it later from Paul. And the systems work group should bring the things more together. So it creates a system with all the parts which were created. The verticals as such, uh, starting with the aerospace, this is the latest use case working group, but there is not yet the full use case. It still gets all the traction of the different groups, aligning what could be common sense for aerospace, avionics, and so on. The automotive as such start with an instrument cluster from AGL. You see it in the right. You get here updates also about both parts tomorrow. And the last part to mention is the medical devices. Here, it's a very nice example because it's an open source, open APS, artificial pancreas system, which was taken consideration. And what I really like about this is that it's coming from an open source initiative put on a Raspberry Pi and really fulfills a safety use case in the open where the users take the result on their own risk, but you can see a very vivid community and a lot of users in there. So it's really worth to also check the link after this when the slides are published to just follow what Dan M. Lewis has done to all this. Right. All this works of the working groups get together in different artifacts and they are basically put together. So you can see the OSAP, safety architecture, features, systems, tools, and skills, they all interact with each other. So it's basically a link, one goes into the other and should create deliverables in different forms. But you cannot simply do something in this group without having a context. So you need to tailor your system. You need to say, in which environment am I operating? Where do I come from? And there may be also domain specific requests. So therefore, automotive, medical, and aerospace may have similar requirements, but also others, and bring the things then together into ELISA deliverables. These kind of deliverables are mainly in the scope of elements and software. So one example could be the Meta ELISA from the automotive work group. And then from process perspective, like how you do a system theoretic process analysis, I'm pretty sure we hear about something later. Systems work group try to create a reproducible build. We have tools like code checker or the workload tracing, which start in the medical devices work group. The architecture also contributed with call tree. And then a lot of work, like for safety, always important, is the documentation part. And so also a little bit of the work we see here today and tomorrow is about the documentation. And if you want to get involved, we have a lot of mailing lists. So you can subscribe, you can join meetings, you can read the content. We're currently migrating a little bit from Google Drive, Google Docs to a more accessible way with having more and more visible in GitHub. So maybe one of the other link will change here, but here you will find a lot of information. And by this, I guess I'm perfectly in time with my 10 minutes intro to give enough room to also hand over to the next speaker. And for this, I say thank you for the very first 10 minutes. Always feel free to reach out on the mailing list or to me directly. If you want to hear more, you can also go to the ELISA webpage and get the contact information. So thank you so much for the first intro part.